I am now. Thanks for reminding me. So it happens you don't get to do something for a week, you forget everything.
So sorry, Dennis, can I just ask a question again, if you don't mind?
Go ahead.
We'll say, for example, if you pick one of them as PPE, you give a reason why you use PPE, is it?
It needs to go deeper than just PPE. PPE is only a part of the whole hazard situation or risk assessment situation. It's one of the elements that's one of the things you would use. But what else is there?
Confined space, those kind of things.
Yeah.
Okay.
Yeah. They drive the processes, they drive the rules that you put out, that you take out of the toolbox to decide to govern your actions and decisions that the things that you make. Whole purpose here is step back from the process, and you do these. A lot of people can do these or will do these things in their sleep. What I want people to say is, well, why do you do this? If I was there the first day with you, and I've never worked in health and safety, or I've never worked in risk assessment or hazard assessment or any of that sort of stuff, and I'm tagging around with you, I'm following you around, and you're out there doing your assessments, and you're out doing this, you have a certain clipboard, you have a certain this, you're looking at certain things, and I'm the annoying child beside you constantly saying, why are you doing that? And why do you have to do that? And why do we have to check this? And why do we have to go there? And why is this looked at? And why is that not looked at? It's what's governing what you're doing, the practices, the acts, all the laws, the things that are making you do what you do. Show that you understand the reasons for your actions, not just that you're following a rule book.
So do we select a few of them and just discuss them, or is this general?
General.
Okay, we're not using headings.
This is quite general.
Okay.
This is quite general. If you want to pick an example and work with an example as you can take a general topic, and then if you're looking at, for example, you mentioned PPE, you might then refer to, for example, in PPE, this is why we look at this, and this is why this is needed, and this is the COVID legislation has said we must have this provision, we must provide for these masks or this sanitization or whatever. And then you can step back out into the general again when you're talking about something else. So you can dip in and out. If you're using an example, you're going to be specific, but you're talking about the overall legislation, the overall rules, regulations, and things like that. The reason I want you to look at the more general concept is if you tie it into something very specific, you may as well be saying that you're doing a specific health, a specific risk assessment, which is not what I want in this assignment. This assignment is meant to be general. The next assignment is going to be focused. This assignment is to show me you know what laws, what regulations, and why they are there.
Okay.
What are they trying to do? What are they trying to achieve? What are they trying to prevent? What are they there for? Because they're the things you put into place every day. They're the things that drive your job, that determine your job, that determine the work you do in risk assessment, hazard analysis. So think of me as either as an annoying boss who's you're out there doing all this research and all these analysis and all these inspections, and you have a whole group of people working in your organization who think you do nothing but look for trouble. That you're only there, the other Grim Reaper, you just turn up looking for problems. So you now have to sit down with some of these annoying buggers and you have to explain to them, well, actually, here's why we do what we do. Here's the rules. Here's the regulations behind it. These are the things that we're governed by, that we have to do. And this is why we do it. Then the next one will be, okay, now go do a hazard analysis. And we'll give that out in a few weeks' time when you're back from the midterm or the reading week, as it's officially referred to. Okay? Clear as mud? Someone said to me one stage, as clear as mud in a dark beer bottle in a coal cellar with no lights, to a blind person. Any other? I switched off the chat thing here for a second. In general, that done the start again, but I think I'm now recording. Yeah. Any other questions or thoughts? As I say, yes, no, maybe so. No, okay, perfection. Let's scoot back down to, thanks Alan, thanks Louise. Just let me scoot back down to where I was. All good, that's what we want. Where the heck am I going? Pass all that. Did all that for last week. We're down here, models. Okay. Okay, we started on some of the models for the session that I pre-recorded for last week, but I felt there was so many of them there and so much going on. I just said, look, I'll do half of them and I'll do the other half tonight. So we'll get through these, and there's one particular one that we're going to be covering in a bit more detail tonight, and once we finish that, we'll be finished for this evening. Just making sure, yes, we are still recording and everything's hunky-dory. We are good. Okay, so we're going to continue with this and looking at some models. And there's just a nice little graphic here to start off the process. And of course, nobody can read it because it's too damn small. So I'll make it just a little bit bigger. See if I can center it a small bit. There we go. First time I saw this, it caught my eye on one thing in particular. You have all the kind of the main topics and models across the top, up on their side there. You have two of the big ones to the left. You have the Six Sigma DMAIC, and you have the supply chain risk management IMPARC. And using them as a template, it's held across all of the other tools and techniques like scenario planning, Delphi forecasting, brainstorming, FMEA, and so on across the page. And the first thing that caught my eye as the first thing I check for when I look at these sort of spreadsheets, these sort of situations, is which one does it all? Which is the one that does it all is the one we should be using. And the first thing that catches my eye when I look at this toolkit is none of them do everything. In fact, some of them are remarkably light in their purpose or in their potential, and yet they are widely used. The one we'll be looking at in a bit more detail later on is the failure mode and effect analysis, affectionately known as FMEA. Used fairly widely. And yet, of the four elements they give here, which is your identify, measure, and prioritize, or analyze, reduce, control, or if you take the Six Sigma, define and measure, analyze, improve, and control, the FMEA only does one of them. It does the first one. It's great at identifying, but it doesn't actually do any of the others. Statistical process control, process capability analysis, and simulation modeling are about the best of the rest because they cover 3 items. They tick out the box on 3 items. And probably of those, the one that will get used one of the most will be things like statistical process control. Because SPC is a continuous mapping. It's also a lot more objective in your modeling. Because you're taking actual figures and you're mapping those figures so you can then graphically see where you're going, what's working, what's not working, where are we sliding. We used to use SPC for every day to track production. Every day I would receive the tonnage produced by each production department, and I put that on a table. So as the week went on, they could see what the process, or well, yesterday you did 20 ton, today you did 25 ton, what happens tomorrow, the day after, day after, day after. And and then at the end of the week, we'd say, well, that's what you did across this week, and that's what you did across last week. And we could actually look at that was your week over each week over the last month. How you could see is your current week as good as, better, or worse than your previous weeks. And that is probably the most accurate in terms of managing potential issues, because if you start to see a slide, you can jump on it. You can start questioning, why is it worse? Why is it deteriorating? But that's not necessarily picking up on a hazard. That's just picking up on performance. So even at that, it's not giving you an awful lot of what you're looking for. Hazard analysis is essentially a subjective process. It's looking at a given situation and wondering what can go wrong, and then how big an issue is that thing that can go wrong. In fact, it could be argued, a little bit controversially, that a lot of what we talk about in risk assessment, hazard analysis, both sides of the same coin, could be put down as being subjective. It's experience, it's opinion, it's depends on a person's view. You could have a person who's very goal driven in their outlook, and they don't necessarily see hazards, or they don't necessarily see issues. They just see the goal, and that's all they're going for. Equally, you could have a person who's the opposite side of the goal driven, and that's the person we would know as a problem solver, and they're only looking for problems. They're looking for the hazards. They're looking for the issues that need to be resolved. Some people will say they look for the negative. Now, it depends on which of these two people conducts a hazard analysis, will have an impact on how many hazards or how many issues are going to be spotted, are going to be picked up, or how many are going to be reported, and what weighting will they be given. And that then, to me, makes it a little bit subjective in its approach, in what happens when you do something like the statistical process control. It's black and white. It's objective because it's past tense. What was produced in the last hour? What was rejected in the last hour, or the last 4 hours, or during the course of the shift? It's quantifiable. It's definitive, and unless you're falsifying records by underreporting, then it's there in black. It's there in a physical, tangible way. It's a record that is properly recorded, properly done, providing the equipment that you're using to measure it is calibrated correctly, it's picking up all the right information, and all the other stuff is done correctly. So it becomes a little bit more of an issue when we're trying to analyze this. It also depends on decisions made by management. I mentioned the space shuttle disasters that happened over the last nearly 30 years ago now. Over 30 years ago now. Is it 30? No, it's nearly 30. Yeah, it's over 30 years. It's 86. Looking at those, they knew there was a problem. They knew there was a hazard, but pressures drove it to launch. The one that went up and lost the tiles, they knew the tiles were gone. There were videos of the tiles falling off as the machine, or the shuttle, was launching. I've always thought, when I heard about that one happening, that's one they could have actually left up there, because it was up at the space station. So they could have left it at the space station. They could have got a Soyuz to bring up spare tiles. They'd already been doing spacewalks. It would not have been a major issue to go out and try and find some way of attaching the few tiles that came off before they brought it back. All they would do is extend the time that they were up there. But they insist on bringing them back. So obviously some people decided that that was an acceptable risk. The hazards weren't as severe. It'll be fine. And unfortunately, it was that severe, and it did happen, and the rest is history. And the world is down 14 astronauts. So we have to be very mindful in this when we're doing anything like hazard analysis. There is a certain subjectivity involved in the process. There is no hard and fast process that I know of that will just measure and do everything for you. Once you have human input into something, you move away from objectivity and you move into the realm of subjectivity, which then depends on the person to an extent. And from a purely academic perspective, that makes it a less accurate process. What we have is it is challenging to try and quantify at a risk will happen. It's very difficult to do that. We can identify risks, the themes around the risk. We can place value on their occurrence, but who puts the value on it? I might say it's significant. It's a huge risk, and it's very important, and it's critical that this does not happen, because if it does happen, the whole place is going to be on its ear, and the whole thing is going to fall flat in its face, and the world is going to end, and everything's a total disaster zone. But if others don't see the same way, that's how we that's how we lack compliance on things. That's how stuff happens. Somebody pointed out last week after those terrible earthquakes in Turkey and Syria that, and I know there's been some contractors arrested over the weekend in relation to the buildings that they were involved in, the developments they were involved in. Somebody pointed out, have you noticed that, you look at a whole row of buildings and some fell and some didn't. And the fear they have at the moment is that the ones that fell didn't comply with the requirements of the standard, because they're being built in an area that's known for earthquakes, almost along a fault line. And other buildings that didn't fall, possibly because they had to go and investigate them, were built to the required standard. Now, if that is proven, then you have people who decided that only partially comply with the rules. Didn't see the importance of doing the whole thing. So the risks might be identified. That doesn't mean they're going to be complied with. That's the subject part, Jimmy. Where does reasonably foreseeable fit with risk analysis? Legally, it fits under the heading of what they know as the reasonable man, or the reasonable person thinking. Originally used to be known as the reasonable man. And the idea was, ask an actuary, that'll depend on what they say and who they are. The idea basically is, possibly. You could possibly use something like the Bolam test on it. But it depends on how the information is gathered for inputting. If it's left to opinion in any sort of way, shape, or form, even to the selection of the criteria, then the result is potentially skewed. What we're looking at here is something that's extremely difficult to pin down. You can the 3 points in green there: identify the risks, place a value, and a value on their mitigation, their contingency. You put 2 values on it. And if you do that, the fact that you have to place a value on it, and you put a value on the mitigation, who puts the value on? That's human. And human input is a perspective thing and varies depending on the individual person's filtering system. It's a behavioral thing. You might get some sort of standardization in places, but that doesn't allow for complacency. It doesn't allow for people's attitude. I mean, I met somebody at one point who admitted to me that when he's on a motorway in Ireland, he won't drive at less than 130 to 140 kilometers an hour. And in fog, he won't drive less than 130. He gets into the outside lane and he will do 130 in fog. That's kind of what I thought too, Louise. I think I actually said that to him. And he said, no, he said, we'll be out in the outside lane in a fog. They'll all be driving very slowly in the left-hand lane. And I said, in a dense fog, you come across somebody who has no, who's only driving on their running lights, which is not your tail lights, and you're into their exhaust pipe because they pulled out or go around a truck. And you appeared out of nowhere at 130 kilometers an hour in fog. Whatever about doing it on a beautiful sunny day where it's still been stupid, but at least somebody you have a chance of seeing ahead of you and they have a chance of seeing you coming. I'm going to hope in fog. And this guy, he admitted to me that he would drive at that speed in fog. Then a couple of days later, he offered to meet me. We were going to meet somebody. He said, I'll pick you up and I'll drive you. And I said, it's all right. I'll go there myself. I'll find my own way there. If I have to hitch it, I'll find my own way there. He's still alive, yeah. As far as I'm still alive, anyway. I haven't seen his death turning up. I'm sure the people that he blasts off the road are still alive too, just about. But that's just his perspective. His thing was it's quite safe to do that. So his putting a value on risk of something happening would be very low, and his risk of something, it just needs another like himself. Yeah, I would say the likelihood that that's a hell of a lot bigger than he's given himself credit for. Or the likelihood of somebody slow pulling out around a truck. I'm in Limerick tomorrow. I'm on the road at stupid o'clock in the morning, and I was down there last week. And coming back up, I was just coming up towards pulling out to overtake a truck, and the car that was between me and the truck, he decided to pull out and did 100 to 110 to pass the truck on the right-hand lane of a motorway, which is stupid in itself. Could be a nervous driver. You get up beside these big trucks. It was a very small car beside a very big truck. All of a sudden, the big truck looks even bigger, and people got nervous because they braked as they got up to the back of the truck, up beside the truck. Now, if he's coming whizzing along in a fog at 130 kilometers an hour, he ain't going to stop. He's going to be either straight into the back of that car, or he's going to veer and he's going to whack the back of the truck. Either way. So the point I'm using him as an example for is his value on the occurrence of something that he's going to crash traveling at that speed is low. And his value of his mitigation is the car has good brakes. The road is wet. I can't see where I'm going, but the car has good brakes. It'll be fine. To me, it's a complete lack of understanding of the whole rule of motion, basic physics. But this is what I have. This is an issue I have around risk assessments. There are limitations to that we have to be mindful of. And I think the first one we have is we can't account for all of it. Sometimes we get it wrong. And that's what we have to be careful of. The Bolam test that Jimmy mentioned, it's it's still judged. It's a test that's judged by medical professionals, by their peers. And that's kind of an aftermarket test. It's after the process, which was it's used in medical practice to check your culpability. So in other words, was there anything else you could have done? So for that to happen, we would have had to conduct our risk assessment or our hazard analysis. Something would need to have happened despite the analysis. So in other words, it still went pear-shaped. And now we're holding the tribunal to work out, did we get it right? Was our hazard analysis robust enough? It's actually going to be, they're doing it in the district hospital here in Carlow at the moment after the weekend. We were awoken at 3:30 on Sunday morning by rescue, which is the one out of Waterford, I think it's 115 out of Waterford, hovering at less than 200 feet over my house and crawling up and down the road. 117, thanks Jimmy. I keep getting mixed up. I know 118, one in Dublin / Kildare. 115 is over the west, isn't it? 115 is Shannon. But he was hovering for an hour and a half. The reason I say 115 is because it's the one that keeps turning up at the Aran Islands when I'm on the Aran Islands. He was over and around our area from 3:30 till I actually fell back to sleep after 5 o'clock. He was still around. It was an elderly person, 87-year-old, walked out of the district hospital, which is not supposed to be possible. And she was found on Sunday morning, unfortunately, not far from the hospital, but found deceased behind another building, not too far from the hospital. I presume autopsies and everything else will be done. So they will be doing something like a Bolam test to work out was everything that could have been done, and checking the security and how did it happen if she managed to walk out of a building and so on. Pretty much undetected, although security cameras picked her up, but nobody thought of stopping her, unfortunately. You know, Jimmy, you point out, so thank you, that the Bolam test is great, as I say, it's the after effect thing. It's still not picking up on what the hazards might be. It's only seeing, did you do the right thing? Could you have done anything else? So it's the protection game. It's the belt and braces, but it's after the horse is bolted. See, that's one of the arguments, Louis, is, should we be overcautious on these things, and then what's that going to do from a management perspective? We got to bring the management back in into the discussion now. If you start going, keeps getting pushed to more caution, at some point it becomes so restrictive that either people will ignore it because it's too restrictive, and if that stuff never happens, or management will make a decision that we're being overly cautious and we don't really need that level of restriction, and they'll override it. Or you'll be asked to conduct the analysis again, but not to be so pedantic about it, even though you can arguably justify all of the risks, all of the hazards, all of the issues. I mean, you can put in anything, you can put the most common issue, the most common hazard in all jobs is slips, trips, and falls. And it's very easy for someone to stumble over something or trip over their own feet and fall. But what can you do to prevent that? You can have the floors made in such a way they're completely non-slip and everything is done perfect, and the person wears the proper types of footwear, and they can only carry one item at a time, or they can't carry anything. I remember my father telling me when he went into the post office, he worked in the post office for many years. He was telling me that, when he had come from manufacturing, he worked in a furniture factory making and carving furniture. He's a cabinet maker by trade and a fantastic wood carver by trade. But back trouble meant he had to leave the trade before it killed him. And he got a job in the post office. And before he got his own postal run, he was only his first couple of days there, he went out with the post vans to empty the post boxes. And he arrived, I still remember him telling me, and I may have said it in this class before, he arrived at the railway station in Cork, and there's a post box on the platform in the railway station, or there was anyway. And he got out of the he was with the driver. He wasn't driving. There was another guy with him who knew the route. And as soon as it pulled in, my father knew what the job, being anxious and enthusiastic, jumped out, grabbed the bag, the big heavy bags that used to be made in prisons, the heavy ones, grabbed that over the shoulder and started running to get in and open the thing. And he heard the driver yelling at him, "Stop, what are you doing? I'm going to get stuff out of the bus. Why are you running?" So we can get on with it, get it done, move. Because he came from an industry where, you have to hurry. You're on the clock. You get it done quickly. You don't take your time. You don't take your time for anything. And walk. Don't ever run in this job. Okay, so he started walking, and then he got yelled at again. What are you doing with the bag? The bag is empty. I'm carrying the bag. I'm going in to open the box. And that's as she got to the box, and he opened it, and there was one letter in the box, in the post box. He put it in the bag and threw the bag over his shoulder. One letter, not a parcel, not a box, just a letter or a postcard or something. Threw it in the bag, closed up the post box, picked up the bag, threw it on his shoulder, and started heading for the door. And again, this guy comes back to him. "What are you doing?" "I'm heading back to the car." "What are you doing with the bag?" "Carrying the bag back." "You don't carry a bag with post in it. Drag it." "But there's one letter." Yeah, it doesn't matter. Drag it. Different standards, but it also gets to the fact that you have this whole thing about what's overkill here. Yeah, if you put, you fill the bag with heavy boxes, then you drag it. He said he felt like a right idiot dragging a very obviously empty post bag across the platform and out the door to the car to put it in the car or the van to go on to the next post box. So you have that balance, Jimmy, as you point out, the potential for negligence versus a client's appetite for risk. That's what we're balancing out all the time. Negligence can also be lack of compliance. Negligence slash client's appetite for risk can always come in depending on how restrictive that people feel your analysis is. So if you're erring on the side of caution, you're going to get met with resistance of people saying you're uber cautious, you're way too cautious. And in that situation, people will either request the analysis be done again. People will decide to avoid it. Sorry, Damien. See your thing here now. Senior managers to accept the responsibility. Yeah. Yeah. So you're basically it's a committee decision nearly. So one person will decide it, but if it's felt that it's anyway too strict or whatever, we can pass it up the line to managers, up the levels, and let them make a call on it, see if they're willing to accept it. And that's actually, that last sentence, Damien, is the killer one. It's up to senior managers to accept the responsibility. And if a senior manager doesn't actually know the role, doesn't know what the situation is, they may not be willing to take that responsibility. And it can actually be easy for those managers who may not understand the whole process or ramifications. It can at times, and I don't want to belittle these people, but it can at times be easy to dissuade him, because the higher up the ranks it goes, the more some of these managers would be interested in, what will it cost us if we do that? How much does that cost? And if it starts, you start moving from what's a risk to the cost impact. Once you start moving into cost impact, you change the parameters, you change the ballpark completely. The whole focus changes. It's no longer a safety situation or a hazard situation, it's a financial situation, which changes the dynamic completely. I mean, I've seen senior managers over my time, and they are extremely risk averse. But when they get to a situation where it's put on the table in front of them and they have to make a choice, they're a little bit cagier about. It depends on who they are. You're back to individual choice. Some of them would be very nervous to be putting their name on the document to say no, ignore it. And there's equally others will say, well, my justification is it would cost us too much, or slowed us down too much, or delayed too much, or whatever. So I made a call. I made a judgment call, and oops, it didn't work. If something goes wrong, again, I go back to Space Shuttle. They knew the O-ring was faulty, but they had cameras of the world on them. This was going up. It was the first civilian astronaut going up, the school teacher going up. This had the eyes of the world on the shuttle launch, and to delay it would not have gone well. So, decision taken, go, even though there's a risk. And that was the day the chickens came home to roost. It's not an easy situation. It's one of these situations that you're damned if you do and you're damned if you don't. You can err on the side of caution. And that's still subjective. That's still, did you err enough on the side of caution? Did you err too much on the side of caution? It goes up the ranks, as Damien suggests, up the lines to management. Let them make a call on it so they can weigh up the risks and decide are they acceptable or not. And if they know what the consequences are, or fully understand the situation, they might make a reasonable handle at it. But if they don't, will they be influenced by how much will this cost? And maybe err on the side of relaxing the risk, relaxing the hazard, relax the view so that it doesn't cost as much. So we're not rejecting as much. We're not slowing production. CYA, yeah, and that's a lot of what it comes down to. I mean, one of the questions a person will get asked is, cover your ass. It comes down to that. You see, as I said, damned if you do and damned if you don't. If you're overcautious, then you're being too restrictive on production. If you're not cautious enough, why did you let this stuff happen? And we've seen it. I mean, it has been seen in instances around the world. Boeing 737 MAX 8. Left out, or programs not turned on, or whatever, assumptions made that pilots will understand, or all this sort of stuff going on, and 339 people lost their lives. And it could have been more, because there was at least one other aircraft got itself into trouble, but the pilots were able to do something to get out of it and get it back on the ground just about. Probably had to go and change their underwear when they were finished, but they got it back on the ground safely. But it was down to something wasn't perceived to be that big a deal until two planes crashed. And even after they crashed, it was still not perceived to be a big deal. They started blaming the pilots didn't understand how to fly a plane. These things happen around the place, but the cost of resolving the problem becomes big. It became very big. It became so big that it cost people's jobs. I think the CEO of Boeing ended up having to leave, ended up resigning before he was actually fired, on the basis that it was on his watch that it happened. And he kind of fell on the sword. I'm sure he got a nice big paycheck for it, but he fell on the sword for it, because it opened up a whole other can of worms of people inside the company who flagged hazards and flagged issues, being told by superiors, by their supervisors, moving it up the ranks to make a call on it, by being told by the supervisors and superiors to basically shut up. And if you want to keep your job, just do your job. So we went from hazard analysis, empowering employees to spot issues and hazards, to potentially being governed by the mighty dollar. Let's just get this done, get it out. We have big orders. Let's get it out in the marketplace. We cut the corners, we cut the risks, or we cut the corners, we increase the risk, but that's their problem. That's the customer's problem. They'll fix it when they get there. The point I'm making here is, it is a very, when you're in this area, you can have all the laws and regulations in the world, and they're designed to guide and to help people doing this job. But at the end of the day, it comes down to a human being standing in a room, looking at an operation, walking a process, and identifying the issues that could happen. The unprotected elevated spots, the potential for slipping or falling or spillage or chemicals or whatever. All of these aspects can happen. And we have this complete one observation requirement by the person conducting the analysis, and two, the filter that these people have in relation to what they would consider or what they record as a potential issue. When I was doing something similar in what is now MTU in Cork, a lot of years ago at this stage, it's still CIT at the time, and it was a Saturday afternoon. I was sitting in a classroom with a group of people, and we were just talking about risk assessments like this. And I remember asking them to imagine that the room they were in was a commercial, well, it's a college room, but imagine it's a production facility or a warehouse. And I wanted them just to look around just the room they were in, the classroom they were in, and identify the classroom, the environment, everything that they're in, any of the potential hazards or risks that they could see or that they could imagine that could happen. And most of them would kind of say things like the suspended ceiling falling down, the light fitting falling out of the ceiling and hitting somebody on the head. We were parked beside the car park, so one or two of them came up with a car parking, but hitting the accelerator instead of the brake and launching through the window of the building. Which, yeah, that would be a potential issue there. And I asked, was there anything else? And they didn't think of anything else. And as I was asking them, a plane flew overhead, very low, a jet, very low. And I just pointed upwards. And they still didn't get it. Where the CIT is located, or now MTU is located, it is directly on the flight path for approach and takeoff to Cork Airport on one of their runways. Literally, Cork Airport is on the hill beside, or just up from the college. The college is in a valley, and it comes in over the north side of the city, and it flies straight over, and it literally comes down. It's level with the top of the hill, so that as it goes over the top of the hill, that's where the runway is. And at night, if you look up toward towards where Cork Airport is, you'll see the lights at the end of the runway. If there's a plane coming in, you'll see it lit up. So, conducting the assessment, did anybody think maybe a plane loses power coming in and comes down, or taking off loses power and taking off? Maybe not as much because it's kind of shooting off a ramp coming off the end of the hill. But if you're coming in, it misjudges it. Maybe loses power, throttles the power back too much, whatever. Could come down. Just the fact that the planes are so low over the airport, they don't have much recovery space, and they're straight out of hill. It's just it's just being aware of the stuff that's around the place, but then it's subjective. So what to look at is, if I can get this moving, there we go. I'm going to take a look at this. It's one of the more popular models that's out there that's used as a way of identifying what can go wrong. It's literally, as you saw from the initial graph I put up at the start, it is really just a first step situation. It's really just it tries to be a catch-all. And there is elements in this that will allow us to be somewhat objective, but there's still gaps, just like there is in all of these sort of tests. It does allow us to identify potential areas that will have biggest impact, potentially to our customers, to our operations, to whatever. It can help us identify where things are going to fail. So we look at the hazards, look at the issues, the dangers, the problems. And it's trying to do it before they can become dangers and problems. Or where the process is going to fail. So it's quite pointed in what it does. It's an assessment of what can go wrong. Has anybody here, just before I go into it, has anybody here ever used FMEA? No? You did. Perfect. So Candavilli will take over if I get into trouble then. Or he's going to come back as I go halfway through this and say what I said was a load of rubbish. Thanks. It's always good to have somebody who, can pull you up on things. Not. Okay. So 101, yes. So I'll assume that nobody's rushing up saying yes, 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 that most people haven't used it. Okay. Where can it be used? So somebody, for example, there's a couple of examples here. Manager is responsible for moving manufacturing operation to a new facility. He wants to be sure the move goes smoothly as possible and there's no surprises. So the actual movement of something, the transfer of production to another area, whatever. Design engineer wants to look at all the possible ways a product design could fail, so that they can build robustness into a product. When you think about it, there is actually over the last, since mass production, I suppose the last 100+ years, since Henry Ford's day, with the modern mass production, companies have actually been building obsolescence into production processes on the basis that if something goes wrong, people will buy another one. People will either buy parts or they'll buy another unit, another item. Which is something that is being addressed using the circular economy concepts and green manufacturing concepts that are being brought forward and being pushed more and more. Sustainable procurement, sustainable management that are being pushed more and more in businesses at the moment. There's a move away from this obsolescence situation and more towards robustness and longer life cycles and repairable or upcyclable, so things can be reused and built on and developed as they go along. So we will do the FMEA to see what potential things can go wrong. What robustness do we need? For engineer might look for ways where software might fail when it's scaled up for larger databases. So can it handle the volume? Can it handle the speed? Can it handle the density of requirements and formulas and stuff that's going to come at it at the same time? Can it handle multiple points of data at the same time? You know, you hear sometimes of, particularly, you know, if there's a new concert or a sports event coming up, that the Ticketmaster crashed, that the server crashed, and it overloaded. Once they opened up for bookings, the system overloaded and it crashed the server. Well, that's what they haven't done. You know, they haven't checked what's the risk of something going wrong. If what's the maximum that our system can handle at a given time, the number of queries or contracts or demands or pieces of business can it handle at a time. The mitigation for it could be the mitigation for something like that could be that you might put some sort of a counter or something to slow the server so that it'll accept people in, but once it gets to a certain number, it puts people in a queue. And as people do what they need to do and get out, it lets a person in, one out, one in type of thing, or lets a group of people out and group of people come in. So it puts people in a queue rather than everybody hitting it at the same time and just crashing the system. That can only happen if I've identified that there's a potential risk that if this thing is popular, the whole system is going to crash on me. Yeah. They have assessed the max. And sometimes you see mitigation is where it's where a risk is seen to be a high enough level that we have to put a band-aid on it. We have to put something in to make it, to fix it. So it's a case of, right, when it gets to that level, how are we going to make sure it doesn't pack in at that level? So we're putting that extra piece of a fix in there. So if it gets to a certain level or above a certain threshold, that the system will be able to handle it. We'll either have additional capacity kicking in or something will be done to try and relieve the pressure in it so that it doesn't all go pear-shaped on us. What happens if there is extraordinary demand? That may not be picked up by our mitigation. Your mitigation might be, we'll deal with 1,000 calls a minute. And so we kind of fix it that if it goes to 1,100, 1,200, 1,500 calls, we'll handle it. It's, you know, that's 50% over That's 20 to 50% over what we'd expect. But if 3,000 calls come in, that was not even thought about. That it was perceived that would be outside the ballpark. That's not going to happen. 1,500 would be about the most. Garth Brooks, yeah. People didn't expect that it would necessarily have the same following this number of years later. It happens regularly. I mean, the strange thing is, Ticketmaster regularly end up getting the system crashed. There's bookings coming from too many places, and they can't handle it. And because it's an automatic system, it means that they're not building enough redundancy into the actual servers. This is where cost comes in. It's possible to put a system in place that will manage all of that, that will cope with the huge volumes. Those additional servers cost money. That additional capacity costs money. That additional programming costs money. Money reduces profit, because you can be sure it doesn't come cheap. It's not a case of go to Currys and buy another USB key. This is big IT stuff. And there's this point, again, within the management structure of any of these companies, that where does our mitigation for risk become added cost for a maybe? Added cost for something that might not happen. When you start adding that bit in, we start kind of, oh, hang on a second, what's the point of this? What's the point? Why bother? We don't need that level of protection. That could be the one time. So we've mitigated to the fact that the orders or the demand will go above certain percentage, a certain run rate, a certain capacity. And that's our threshold. That's where we protected ourselves until. But if it comes in higher than that, a little bit higher, we can possibly cover it. Bit higher again, the wheels are starting to wobble a bit. Climbs a bit higher again, and we can hear Scotty from the old Star Trek shows going, I cannot hold her, Jim. And if it goes much above that, the dilithium crystals implode. And we got a problem. Well, where do we draw the line? In any sort of hazard analysis, risk assessment, we have the same argument. We have the same discussion that can happen all the time. And depending on the line gets drawn depending on some maybe past evidence. When I was ordering for promotions and things, I know this is no major life-threatening situation, but when I was as a purchasing manager, risk assessment comes in there too. I'd get a promotions calendar, and a promotion would last 2 weeks, and I'd get a figure from sales and marketing as to how many units of the promotional product we were going to sell every week. So they may say we'll sell 10,000 units a week. Just 10,000 labels, 10,000 packets, whatever you want to look at it. And it's running for 2 weeks. So that means I need 20,000 packets. And I would normally add between 25 and 50% to that figure, just to allow for production wastage, to allow for possibly a small surge in orders or whatever. So I would be ordering 25 to 30,000 labels. So I have 30,000 labels, which is technically 50% more. It's 10,000 more than the capacity for 2 weeks. Now, what I found when I started doing that, for a number of the promotions I was running, I'd have 30,000 labels on site, ready to go. And they start producing the product into store on a Monday, goes in Sunday night or gets out on Sunday night into the store on a Monday. And by Wednesday, I'm getting a call from production. Have you any more of those labels? We're out of it. Hang on, there was 30,000 labels produced. Where the hell are they? Oh, we're gone. They're gone. They're gone. They were all ordered. They're all gone out. No, they can't be. They can't be. There's only supposed to be 10,000 going out each week. So no way you've gone through 30,000 labels in 2 days, 3 days. Yeah, they're gone. Contact my stores guys. No, they're definitely gone. The last lot of them went into production on Tuesday. But there was 30,000 labels there. Yep, they're gone. All of them. Now there's the panic ordering. There's management screaming at you. You didn't get enough. Why didn't you get enough? You try to explain that I was told to get 20. I got 30. Not my fault. You ran out of the damn things. Panic, chaos, weeping and gnashing of teeth, accusations. Next time that promotion's coming up, you ain't catching me like that again. 10,000 a week. Not ordering 20,000. I'm not ordering 30,000. I'm going to order 50,000 labels. I order 50,000 labels because my history says the last time I took a risk on 30 and it was nowhere near enough. We were out of it in 3 days. So I'm not being caught that way again. Promotion's running again, so I'm going to order 50,000 labels, which is, I'm still getting a forecast of 20. And now I'm ordering 2.5 times what I need. I'm ordering 50. And we use 10 in the 2 weeks. And now I have 40,000 labels left over. And again, I'm getting people, why did you order so much? Because the last time we ran out. Yeah, but that was the last time. So you overcompensated. Your risk assessment was wrong. You overcompensated. You ordered too much. Now, what are we going to do about that? We have to run another promotion now and try and shift them, but we can't run another promotion because if we run another promotion, it's seen that we're running a promotion, and that's just people just going to stop buying. Welcome to risk assessment. In the hazard situation, you know, we have the Health and Safety Act. You have the Safety and Health and Welfare at Work Act. All these regulations, and I've seen companies breach every single one of them. I ran a course in a nursing home at one stage, and I was told that the staff had to buy their own uniforms, and none of them had steel-capped boots or shoes. They were all wearing moccasins or moccasins, whatever you want to call it, soft shoes, comfortable footwear for being on your feet all day, but not very good when you have an elderly patient stomping on your foot or rolling a wheelchair over your foot. And yet, when you read the Safety, Health and Welfare at Work, it tells you that the employer was responsible to supply suitable PPE. But they neglect that bit. It's not seen as a risk. They're better when they provide their own. We're better employers for that because we're allowing people to do it. This is the complexity, the danger we have in this game. It is literally a case you're damned if you're doing, you're damned if you don't. When we look at the failure mode itself in this FMEA, it's the way a component, subassembly, product, input, process could fail to perform its intended function. In other words, what can go wrong? That could result, it could be the result of upstream operations, something somebody does earlier in a production process. It's the way somebody preps something. Downstream operations could fail because of it. You could have a situation on a building site where a pallet of of bricks isn't secured properly on a pallet, or the pallet isn't robust enough. So when the loader picks them up and hoist them up onto the top of a scaffolding for builders up high in the scaffolding, as it's coming in over, the straps breaks, or the pallet disintegrates, and bricks start to shower down. That's because of the way they were secured in the first place. It's maybe because the operator of the lifter, the loader, didn't check the straps before they moved them, or whoever was guiding didn't check them, or used a strap that was out of spec, or old, or frayed, but they were in a hurry. It was the only one they had, so I had to be grand. It worked every other time. But every other time it was holding up something. It was bringing up WAVN pipes. This time it's bringing up a big heavy pallet of concrete, or a pallet of concrete blocks. We haven't. It's taking that step back and looking at what can go wrong. It's identifying the things that can go wrong, but this is where subjectivity comes in. I might see things that might go wrong, other people mightn't see. Other people might see things that go wrong that I miss. And that's going to be based on my training, my understanding, and my measure as to what is a risk. What is a potential failure? And this is where I think things become quite weak in any sort of hazard or risk assessment. It's the first part of subjectivity, just identifying what can go wrong. I can be erring very much on the side of caution, and I can overstate it, or I can go the opposite way, and I can say that would never happen, and bang, it happens. You know, there are things that are around this world that will say that would never happen. It would never happen like that, and nobody ever thought that a microorganism that started in China could shut the whole world down, and literally shut the world down. And if you saw it in a movie, you would say it's far-fetched. You'd say, not a hope, that's ridiculous. But it did. And it's still having a knock-on effect with people. Shanghai only reopened over Christmas, or just after Christmas. China as a country only reopened after Christmas, to the extent that they're now talking, it was Hong Kong or all of China are talking about offering something like 500,000 free return airline tickets across 6 months or something, to encourage people to go and visit, try and get people back visiting China, just to get people moving again. New Zealand never thought they were going to have so many cyclones in their summer period. And my daughter's on lockdown for the second time in a few weeks because of the cyclone coming through. It'll be Wednesday their time, which is tomorrow evening our time, before they reopen. Nobody thought that was going to be a problem. So we start with the why something can happen. This is where we're looking at process improvements. We're looking at how we can do this better. We're looking to identify and eliminate concerns in the development of a process or a design or in an operation. We're trying to identify the issue. This is why we do the FMEA, where we try to find what can go wrong Look at improving internal and external customer satisfaction. And it can help if we look at our assessments from the perspective of a customer, from the perspective of somebody, rather than just walking through and say, well, that can go wrong and that can go wrong. It's looking at it from the cost or the impact on a person or the impact on a customer, internal or external. The external customer is a little bit more important than the internal, marginally. The external is the person, your ultimate customer, who's going to pay you money for your product and your process. The internal customer is the next step in the process. So in a building situation, the internal customer could be the plasterers, could be the electricians or the plumbers. And if you haven't got if they get held up, then they're looking to be paid because they may have given up another job to come and do your job, to do the wiring or do the plumbing, but you're not ready because something went wrong in the building. And it's trying to manage the expectations. It's trying to make sure that when they do turn up, that this place is ready for them to do what they need to do, to run their cables or to pipes or whatever they need to do. Purpose of FMEA is to see if we can eliminate any issues, prevent an issue before it becomes an issue. But again, it depends on how critical and how stringent we are in our views. Some customers may actually put it as a contractual requirement that a risk assessment is conducted or a hazard assessment is conducted at various stages to ensure that everything is within parameters and is controlled and managed. Things like some of the ISO standards like people to have conducted risk assessments and have recorded their risk assessment and the reports from it, so that if something goes wrong, it can be tracked back to, well, was that picked up and were the correct mitigation steps put in place? Was the correct training done to avoid it becoming an issue? And if not, why not? And sure, it would never happen is not an answer. ISO, as I said, the quality systems in ISO, something they require risk assessments be conducted and hazard assessments of all operations be conducted regularly or periodically anyway, so that you can you're making sure that everything is still functioning as it should be. There's no new risks have come in, especially if anything changes in production or materials. And that even can be down to the way materials are presented. If materials come from the supplier and they're no longer in a bag, they're now in a box, we should be rerunning the risk or hazard assessment, because we don't know. Maybe handling a box is now different to the bag. It might need a different type of opening device, like a knife. At one point, I had to change our process internally. I had two options being given by my health and safety guys, and that was get the suppliers to pack what had for years been packed in 25 kilo bags, cement sized bags. So which means that 40 bags on a pallet, we had a ton on a pallet, so placing orders was simple. 10 tons, 10 pallets, sorted. And we were getting for things like oats and salt and other products like that. The problem was that part of our warehouse operation was to decant those bags into big plastic, what are known as dolabs, to big plastic bins, which would then be taken to production, and they could shovel into the mixes as they needed. The issue health and safety had was I had workers in the warehouse who spent their day decanting 25 kilo bags of material. That means they're repeatedly lifting 25 kilo bags of product. Now, they're not lifting it very far, but they're still lifting it. And that increased risk of repetitive strain injury or of any sort of injury. So I ended up having two choices. Get my suppliers to reduce the pack size, the bag size, from 25 kilos to 15 kilos. That was option one, which wasn't a flyer from day one, because first of all, it screwed up the entire ordering process because you wouldn't get a ton on a pallet, and suppliers themselves didn't have 15 kilo bags. They'd have had to get bags, which would have ultimately cost us more because they'd have had to change their entire production process. So financially, from my supplier's perspective, I was told in no uncertain terms what I could do with myself when I started suggesting that. That left me with one option: get the company to spend 8 or 10 grand on a vacuum lifter system. We got a vacuum lifter put in, which means that the operators could lift a 25 kilo bag with their little finger. So there was no more problem, except for the fact that we had only one vacuum lifter and we used to have two people decanting bags through the day. So we traded on quantity in order to maintain the bag size and to have the vacuum lifter in place, on the basis that one person using a vacuum lifter should be able to do the work of two people manually, especially by the end of the day. So it becomes a costly solution sometimes, and sometimes we don't have a choice. The combination of suppliers telling us there's no way we're not getting you a 15 kilo bag just because your health and safety guy wants a 15 kilo bag. It isn't happening. Forget it. But they say we need to have it, and it's law. Yeah, it might be law, but we're not doing it. Our other suppliers, our other customers don't want 15 kilo bags. We're not doing it just for you. There's times when, no matter what the risk assessment, it doesn't mean you're going to get what you want. What it is essentially, this FMEA is, it is a structured approach, and we'll go through the approach in a few minutes. It's a structured approach looking at ways in which a process or a product can fail. So we're trying to find what can go wrong. We try to estimate the risks associated with those specific causes. So we're trying to prioritize and put a value on not a financial value, but a numeric value on the risk itself. That then helps us to prioritize what actions we need to take to reduce the risks. And we can evaluate the plan. Look at the current control plan. See what needs to change and stay on top of it. When do we get it? When do we do it? Most people will tell you that you should conduct these things as early as possible in the process. But it should all be done anytime there's something changed within the process. So early in a process improvement investigation, you're changing the way you do things. New systems, products, or processes are being designed. So right at the very start, when we're designing something, we'd say, well, okay, well, what can go wrong? What's the downside of this? Which, when people are all upbeat and talking about how great this new thing is going to be, this new idea, this new product, this new process, this new machine, it can be very hard for people to focus on the negative. What can go wrong here? It's all great. You're talking great stuff here. That's all brilliant. But now what's the worst that can happen here? So we're changing something, new process coming in, any sort of new applications, designs that we're bringing across to new applications. We're trying to do something existing process and the existing product maybe that's been adapted or used in a different way. We still have to do a hazard analysis on it. Or after we have something defined, but before a specific hardware is selected. In other words, we should be doing it across the board, from planning through implementation and even post implementation, and any changes along the way. Yes, it could do. It could be used as a deviation investigation, as a, what went wrong and where did we go off kilter. And if we have an FMEA done, we have, this is what we said could go wrong. So what we said would happen, and did we actually comply with the thing? Yeah, sorry, Margaret, no problem. Request for a few minutes break. It is now just after past. We won't be long more once you come back. So maybe if we're back here for 22, would that be okay for people? Yeah, perfect. So back for 22. You'll probably be out here just after 9. We won't be keeping you on late for this. Just run through the rest of this example and then we wrap it up. So yeah, back here for 22. Talk to you in a few minutes. Okay, we get back into this. Get through it. Once the system cooperates with me. Okay, so we've looked at when we would conduct an FMEA. Thanks, Raymond. So very quickly, the history of it. I mean, this goes back to the 60s. It dates, so it's quite, it's 60 years old. Used in the aerospace industry for the Apollo missions, mid to late 60s. It was also used by the Navy in the 70s for a missile product. And then it moved into the automotive industry in the late 70s and then went on beyond that. Like most of these processes, they start in one place and they grow legs and they develop and they're adapted and pushed. And that in itself can be a positive and it can also be a negative. Sometimes we kind of overanalyze, or not overanalyze, but we can overdevelop something and it can actually make it almost unrecognizable. But this has actually been widely used at this stage for over 60 years. Number of different iterations, but it has been evolved and developed over the years, and it's still trusted today. It's still used widely today. But as we saw in the initial chart, it's only used. It's really only an identification. It won't control and it won't reduce anything. It just gives you the heads up for you to then put a process in place, step 2, to actually do something about it. We'll go into this in more detail as we go along, but this is just an example of what the FMEA process looks like. It's a form, just as similar to the one I introduced in the materials that went up last week. It's made up of a number of different sections, which, as I say, we'll go through in a few minutes. You start, let's make it a bit bigger again, with a product or process or something name, who's responsible for it, who prepared it, how many pages are in it, the dates, the usual, a reference number, a revision number, same type of stuff you find in bog standard thing for business stuff. And then we have this table to fill out. We have the step, what's the process step, and that's under investigation. In what ways will it go wrong? What are the impacts of those if something goes wrong? What's the severity, which is a numeric severity? What's the potential causes? The occurrences? What are the current controls that we have in place? How do we detect stuff? The RPN, or priority number. What actions should come out of it? Who's responsible for the actions? What actions are taken? And we have again at the or severity, occurrence, and detection. So we start with identifying the failure, the causes, we prioritize them, and we determine and assess the actions that come from it. On the face of it, it looks quite robust. It's time consuming because we need to do this for every single potential failure, every potential risk, every potential hazard, every potential issue. We would have to do this. That's a time consuming process. And it's one of these things where we can fall into a trap of paralysis analysis, or paralysis by analysis. We can spend so much time looking for failures that we actually don't do anything. So where do we draw the line? A couple of types, and we'll go back into the actual steps of it in more detail. A couple of specialist uses of it. In design materials or design processes, we can look at product design before release to production, which can look at product function. We can look at systems and subsystems in an early concept and design stages. In the current circular economy, green supply chain, sustainability processes, catching issues early and therefore reducing potential failures or reducing potential issues is very important. And using something like this to try and catch things before they become an issue is quite a good step. It's quite a solid step forward. The issue is being back to the point I made at the very start, being objective about the whole thing. In a process, we can analyze manufacturing and assembly processes where they're implemented to see things that can go wrong, what's the likelihood of something happening, and then identifying what we need to do if something does go wrong. So they're great for, this is a good tool for identifying potential risks and hazards if it's done right. And this is the first step here. It's a team tool. This is not down to one person conducting an analysis. This requires input from multi-divisions, multi-departments, cross-functional input. We need to lead it by a process owner or a project manager or a risk assessor, hazard manager, whatever title you want to give them, but one person should lead it. Possibly somebody who's responsible in them has experience and is responsible for manufacturing, engineering, a technical person, or somebody familiar with the tool. But we should also have things like design engineers, operators, process engineers, materials suppliers, and maybe even customers. Do we need a panel of people here? Across the board, you have your design engineers and operators. I see those as two different people. You have your process engineers. They're looking maybe at the reliability, but again, there could be multiple functions there. Material suppliers, customers, quality managers could be in there. You may want to put logistics in there because materials have to be moved and finished products have to be moved. So there's a wider number of people in this process. And the only problem we have that is we put too many people in there, we make it too big a committee and it becomes harder to run the process. It becomes unwieldy. Too many chiefs, so to speak, and not enough Indians. So we need to be careful how we do it, but it is not a one-person tool. This takes out some of the subjectivity because we now have a number of people who have experience in different aspects of the process who can maybe provide a fairer scoring. So the procedure for each process input, and this is one of the things about it, it's all steps. So it's a very long-winded process. It could also be a very simplified process because it can actually, the fact that we have to do all process inputs might help us developing a product to standardize some of the processes or to take out some of the complexity in our processes. So it could be used for multiple purposes, not just for hazard analysis and risk assessment. Start with high value inputs. So for that, you might use something like the Pareto analysis, the 80-20 rule, or ABC analysis, which essentially looks at the 20% of products that would account for 80% of the value, which is only a fifth of the overall products required. Yet it's the ones that we really can't have we can't have an issue with because that's where things will blow up on us. If we go wrong on those, we're in big trouble. Bigger trouble than the risk. There's a risk in themselves. We start by determining how the input can go wrong, which is your failure mode. For each failure mode, we determine the effects and we select a severity level for each effect. Now we're starting to put a number on it on a scale of 1 to whatever. A lot of people use a Likert scale for this, and they would go with something like on a scale of 1 to 5. Personally, in all of that sort of stuff, I don't like an odd number Likert. I don't like a 1 to 5 Likert scale, and I know a lot of academics do like it. I don't personally like it because I think it gives people an out. If everybody scores a 3, what does that tell them? What does that tell your scoring? Everyone's middle of the road. No one's committing to whether it's going to be bad or good. They're just all stuck with it. For me, a much more logical number to use would be 1 to 6. Or 1 to 10 if you want more detail, more finite. The reason 1 to 6 works is that halfway in the 6 mark is 3 or 4. 1, 2, 3, and 4, 5, 6. With 3 numbers each side. Your halfway mark is 3 or 4. It's not 3.5 because that'll be 7. Will be your total. It's 3 or 4. If a person selects 3, they're leaning closer to 1, and if they select 4, they're leaning closer to 6. So you may be middle of the road, but you're still teetering on one way or the other. So I much prefer an even number, just to be a little bit more maybe controversial in some people's case. So you start to select the severity. Look for the potential causes of that. I mean, you've identified something go wrong. Well, what could cause it to go wrong? And again, you score it. You put an occurrence level with that, another number. Then you list the controls. What are the current controls for each cause? And you put a detection level number for each of those. Scale of 1 to whatever. How easy is it? How likely is it that it will be picked up? It'll be caught in time. Once you have all these, you've identified all the hazards and or failures, and you've given a number to the effect, the cause, and the control. You then calculate what's called the risk priority number. And that is basically the number that comes from the 3 numbers you just given. And you will assign, once you calculate that, and I'll talk about calculating that in a couple of minutes. Once you've calculated the RPN, you will then develop, that will give you a number. The higher the RPN, the more, the bigger the priority. I think that's rated as a high number like 10. You will pay attention to it. You assign predicted severity, occurrence, and detection levels, and compare the RPNs. Let's watch. What are the inputs? Your inputs are your cause effect matrix, which you've seen in the ones that we had maybe last week, the materials that were up in the earlier on in the presentations. Process map. So you have to know the process. Process history. Things that have gone wrong in the past. Procedures. What's written down about the procedures. If there's nothing written down, then there's a big risk to start with. Your knowledge of the system and of what can go wrong and what has gone wrong, which links to your process history, and your experience. A new person in the job is not going to have as much experience and possibly knowledge as a person who's been at the job for 5, 10, 15 years. Problem is, a person who's been at the job for 5, 10, or 15 years may also now know about the shortcuts and the ways around things that may then lessen their inputs. You put it into the FMEA process, and that will give you your outputs, which is your actions you require to prevent the causes or detect the failure modes. It also gives you a history of the actions, because the next time you go to run it, the outputs from this running of the FMEA become the inputs for the next FMEA, be part of the history and the knowledge and the experience. As with everything in business, it's got to be cyclical. It's got to go in circles. It's got to go around and around. What you did today is that's not the end of it. You go back and do it again, and you do it again and again and again. And it builds as you go. So let's look at these numbers that you get. Under the severity, you look at the importance of the effect on customer requirements. You put in the impact on the customer. Now, it can be an internal customer or an external customer. Internal customer is the next person in the link, in the chain, the next person in the process, the next production department. The external customer is potentially the final customer of your company. And they're technically, you could argue, are almost more important because they're the ones who can affect future orders. So therefore, potentially, if you're looking at the severity, if it impacts the final customer, the external customer, then potentially the severity score may be affected by the fact that it is an external customer. But yet the internal customer, if it impacts them, then there's a bigger chance that they won't be able to supply to the external customer. So we have a bit of a paradox in that. In the occurrence situation is the frequency which a given cause will occur and create the failure. And you get that from your past data. How many times has it packed up in the past? How many times has that machine let you down? How many times has those operators let you down? If it's a new product, brand new product, then your occurrence is going to be very subjective because it hasn't happened before. So you have no history. If you have no history, you are in guesstimate idea. And I draw attention to the last 2 to 3 years of COVID. And even right now, we are heading for our Patrick's weekend next. And we are heading for Easter a couple of weeks after that. That's not unusual. We do that every year. But this is the first year where we are fully out of COVID. Last year we were still emerging from COVID. This is the first year where we have not only are emerging from COVID, but we've also had a full year of restrictions resulting from the Ukraine invasion and the current ongoing tensions around the world. We are now also, the world is reeling from the earthquakes in Turkey and Syria, which will and have affected the supply of materials that come from those countries. And we have the increased cost of living, increased fuel costs, with all these things that we didn't have last year. And the years before that, we had COVID, so we had nothing going on anyway. So it's very hard to work out what exactly the occurrence frequency is going to be this year. So for businesses, we're into forecasts, we're into guesstimates here. We can't just say, well, what did we do back in 2019 before COVID kicked in? Well, it's irrelevant what we did back in 2019 because all these other things hadn't happened back then, and Brexit hadn't been triggered back then. Brexit didn't come until 21. Was it 20 or 21? I think it was January 21 it came in. So the occurrence bit is grey territory here. Now, if you have history of a production process, you can then say, well, how frequent does these things happen? But in a lot of cases, we don't have that level of knowledge. So we're working off a guesstimate. The detection is the ability of the current control system to detect and prevent a given cause. Can we see it coming? And can we react to it before it becomes an issue? If we can't, have we got, in other words, Have we got a successful this detection system? Have we got a successful early warning system? Maybe something we have learned from previous occurrences that we put in place that's actually very good and very robust. There's a process in place that catches these things before they become an issue. In a quality management situation, you have internal failures, you have external failures. Internal failures are things that go wrong, but they're caught. They are caught in-house before they get out to the customer. The external failures are also known as escapes. And an escape is where something happens, but it's not picked up in the production process. It's not picked up in the actual operational process, and it gets out to the customer. It gets out off-site, out into the marketplace, where a customer buys it, and we now have a reputation issue. We have warranty issues. We have potential legal claims depending on the nature of what goes wrong. Look at the building situations we've had in Dublin with apartments that were badly built, or there was no fire protection put in, or there was something wrong, and the claims that are going around the place at the moment. Look at the claims going around from the mica blocks, the mica in the concrete, and how that's laboring on trying to get things fixed for people, where most of these houses are just going to have to be bulldozed and start again. So they're all escapes. They were not detected before they went out. They were just put out there and hope for the best, and it's blowing up in everyone's face. So we have to understand these three. And bear in mind, if we don't have past data, we are guesstimating. But what I would recommend to a company in that situation is you guesstimate, but as you build some knowledge and you build some experience, so maybe more frequently initially, every 3-4 months, you might rerun it using any little bit of knowledge you've gathered over the previous 3 to 4 months, so that over the period of a year, you've gathered some knowledge, and you can, in a year's time, you have more robust information that you can use, which might give you a little bit better data through which to calculate this. Your scales are generally, they say here, 1 to 5 or 1 to 10. 1 to 10 gives you greater granularity. It's a little bit more, you have a bigger range of numbers, but also it's an even number. 1 to 5, some people like to use it, but I would be very nervous using 1 to 5. 1 to 5 is, if everyone scores 3, I'm getting 0 data, apart from the fact that nobody wants to commit to an answer. So that gives me a problem. The two that you have here, you'll come across this for your dissertations as well, quantitative and qualitative. Quantitative is survey, it's statistical. Qualitative is subjective, it's interview, it's opinion. Qualitative might give you deeper information or more rationale behind something, but it can be harder to put a numeric value on it. Quantitative, numeric value on the spot, but it can be subjective based on whoever's answering the questions. By having cross-functional, you're getting that number from different angles. So that can actually help offset any subjectivity that might be there. Way it can be looked at, it's how you score it. 1 is not severe, 10 is very severe. So the lower number is not severe and the higher number is very severe. Or that's for a severity. For occurrence, 1 is not likely, 10 is very likely, and for detection, 1 is easy to detect and 10 is not easy to detect. It's just getting it right at the start and having the same process. I wouldn't do, for example, 1 is not severe and 10 is very severe, and 1 is very likely and 10 is not very likely. When it comes to occurrence, you're reversing the polarity there straight away, and that's not going to work for you. Well, it'll work for you, but it'll just give you total waste of effort information. So your RPN then is each number multiplied by the other. So if you scored, let's look at this one here. If you scored, we'll say 5 in each, all 3 of them, then your RPN number is 5 times 5 times 5, which, if memory serves, is 125. So 5 5s are 25 and 5 25s is 125. So your RPN is 125. Higher the number, the greater the severity, the greater the risk. And you start with the higher numbers. Remember, you're doing this for all the process, all steps in the process. So they're the ones that need to be looked at most. So if something in this thing all scored 10, you've got a big problem because you're going to get an RPN of 1,000. 10 tens or 100 multiplied by 10 is 1,000. You get a score of 1,000. That is blue lights, sirens. That's the whole shooting match. That's doomsday. That's everything is hitting out. That can't be put on the long finger. That is something that's a disaster waiting to happen. And if that doesn't get priority, then wasting your time. The last on our whistle stop of FMEA is this. Just a quick summary of it. It's looking at where a process or a product can fail. It's looking at the risks of something going wrong. You can estimate the risk because it's putting, I think, as close as you can get to an objective view, because you're getting cross-functional input. If you have a cross-functional input, that's giving you a wider spectrum of figures in there. And if you can multiply that out, and that can give you a fairly robust RPN, which gives you then somewhere to start in terms of, we need to look at this first. This is what we have, where we need to put our mitigations in. This is where we have to put our priorities and our focus in. That helps prioritize the actions that need to be taken, where we need to put the resources. It is a team tool. You cannot do an FMEA on your own. Well, you can, but you're getting a very limited scope. You need multiple inputs. And need to be multiple inputs where ideally people should nearly be asked to score these things on their own. So they're not in a room comparing notes. They're actually doing it properly on their own, and then you're scoring them up, or you're comparing the numbers and totaling up the numbers. Because otherwise, comparing notes is going to make it subjective again. What did you score on that one? I said 6 on all those. I think I'll go 6 as well. That's not a good scoring way. We can use it for design, we can use it for process. The earlier we do any sort of a hazard analysis, the earlier we do any sort of a risk assessments in a process, the better. And that's even, as I said earlier on, in the current sustainability ideas in manufacturing and processes, that's even more important now, because it's where we identify potential problems before we even get into the production and supply, so that we get it right from the start. And then the last point this evening is, we need to look at all the other processes as well. We need to know the process map. How is the product made? How does the system work? It amazes me the amount of times I talk to people, especially in the supply chain field, and I ask them about mapping their supply chain, and they couldn't tell you what it is. They couldn't tell you the process. They didn't tell you how product moves between the system, how it moves through the supply chain. They don't know. They just know they place an order and it arrives. They've never sat down to think about the process. This is the biggest hazard and the biggest risk we can have. People don't know the process. And it's not so much not just know your process. You need to know the process of everybody who's feeding into it. So you need to know how product gets to you, and how it is prepared to come to you, and what's involved ideally in the making of materials that come to you. At least having some sort of a higher level understanding of it, so that you can impact your the decisions around hazard analysis, how you should handle things, what you should watch out for, what to happen next. I remember when I took up purchasing, I went and I signed up on a course and became the company's only packaging technologist. I did a diploma qualification in packaging technology, so I understood packaging. I understood everything from the fluting in corrugated to how we make plastics and the different components of each of them and what works with what and so on. And that helped when it came to getting involved later on with product development, so that I was able to impact and influence their decisions, so that it reduced the risks of things going wrong because they went and bought the wrong stuff. It didn't eliminate them because they still had to listen to what I said, and if they chose not to, we walked right headlong into a problem. But at least if you have the knowledge and you understand the processes and you understand the cause and effects of things, the wider your knowledge, some of which comes from experience, more of which comes from just asking questions and observing and getting in the way of people and to work it out, spending time at the coalface, understanding the process and asking, why do you do that? And not leaving till you're happy with the answer. Then you have that knowledge built up when you're doing this analysis. And with that final point, that is the end of this evening. Thank you very much, guys. Remember, you have no class next week. You get a week, well, officially you get a reading week, college terms. So I'll see you all back here in 2 weeks' time. Take care, folks. Have a good time.